Hello everybody, welcome to my channel. I am Niels van Niekerk from Vanik Developments. I'm the developer of the engine simulation software packages EngMod2T and EngMod2T that we use to simulate two-stroke and four-stroke engines. In today's video I want to show you how to use EngMod2T to simulate the model we created in the previous video. So sit back, relax and enjoy the show. In today's video, we're going to run our first simulation in EngMod2T. We're going to use the model that we created last time called New Project. But before we start, I need to fix two things in the model that I created. Let's just first go there. The first thing is when I created the transfer ports, I was supposed to select a slanted side on the A port, which I did not do. Which I fixed now. That looks much more like it. And then the other issue is that we're running a fairly high performance engine on F-gas that typically runs a combustion efficiency of 92.5%, plus or minus a little bit, but that works quite well for F-gas. Okay, now we've updated the model. Just before we exit, what I normally do at this stage is I create a pack file to have as a backup in case I do something stupid later with the model and I need to recover what I've done. Okay, we're going to run EngMod2T now. What I want to do before we continue is I want to just show you something in the help files. When running it, there's a topic, understanding efficiencies, because I get a lot of questions on this specific topic. It's described here, so if you have queries, please read this. If you have more questions, let me know and maybe I can expand on this topic. Enough of that, let's start simulating. As you can see, over the last 25 years I've accumulated quite a number of projects. Let's open the one that we are interested in. Maximum power is we want it to be at 12,500 RPM. So the first thing we do is we look at the typical exhaust traces at 12,500 RPM to see if our tune length that we guessed is close or correct. So let's run that. You can see when you start in the graphics mode, it pauses here and it gives you a summary of where your model is at and giving a number of things that you can go through. You can see we're showing the exhaust port trace and the cylinder trace. Looking at this, I can normally from experience I know that the cylinder pressure should be this side of the exhaust port closing line, so it looks like our tune length is a little bit too long, so we will go back to that 2T, enter, accept. You will remember last time we used the designer tune pipe, and it says that we used 650 for the pipe bulk temperature, so let's change that to 620. Everything looks okay. Accept, and then save and display, return, exit. We repeat the engine simulation. It remembers everything you selected last time, so we still want to run that and see if we get a better response this time. That looked a lot closer, so maybe we should do a full run and see how that looks. Now to do a full run, we do select the batch run, we switch off the graphics. You can leave it on, but it's usually not the time wasting. Let's call this run we're going to do to xwall was 620C. We have not yet created the RPM file, so let's do 8500 with max power at 12.5. We probably interested to see what the curve does up to around 13.5, and I normally like to use increments of 250 RPMs. Save. Okay, continue. I'm going to pause the recording at this moment because we don't want to look at the screen the whole time while it's scrolling numbers. Let's restart that and see. Okay, that looks quite good. We have peak power at 12,500 RPM where we want it. We had 42 horsepower. We actually are aiming for 45 horsepower. So let's try a little mod on our exhaust pipe and see if it helps. Accept, edit exhaust. Let's add a Venturi to the entrance of the tailpipe. Okay, that's added. Let's rerun it. What I'm going to do now is I want to save the pressure files from this. So this was a modern pipe with 22.5 Venturi. Let's call that let's see what we get from this. I'm gonna pause the video again. Okay, let's restart it just before it's finished and then we see what we get. Max power is still at 12,500 RPM, but we're a little bit short of the 45 horsepower. So what I think we will try next is we will design a different pipe. So the way I normally do that is I go to the exhaust pipe. I first save the current pipe under a new name, so let's call it new project, and I want to use the high performance method to design it. Okay, now it's renamed it. It's still the old pipe, so we go to that, design tune pipe, and now instead of modern we use high performance. We change this to 1.1 and display. The header angle is a little bit high for my liking, so let's go and increase the Mohn coefficient to 1.7 and see what we get from that. 3.92 does not look too bad. I normally try to stay below 4. Some of the really high performance engines you can accept 4 or more, but for this type of engine it's not yet there. Return, save and display. This is what our pipe looks like now. Return, exit. want to run it again. Use previous project. I don't want to overwrite the ones I've saved there. I first want to just do a single run and to see what it looks like with graphics. I'm not seeing anything funny, it looks fine. So let's continue with the run to do the batch run, switch it off, and this one we will call high performance, and we say this is the you can see I can leave it now and read from the RPM sweep file. If you click on that, you can actually open the file. You can see what I've created before, so that's all fine. Continue. Okay, I will pause the video again. So you can see we're still not at 45 horsepower like we were aiming for, so let's go back. I saw no signs of detonation. I will show you in the next video how to test for that. For now, let's just see what happens if we make the Venturi a little bit smaller. Okay, let's just finish the run. We're closer, but we're still not where we want to be. I'm not going to continue along this process. I just quickly want to show you in post 2T how we find the detonation and performance files. Into Stirrup, there's a new folder created with the project that we were looking at. Let's just compare the power of our final run there and the power of our final run here. You can see that the modern pipe gives a little bit better overrun and it looks a little bit stronger in the mid-range, so it's not a bad pipe altogether, but it still needs further refinement, which I will do at a later stage. That's enough for now, I think.